This work has been done by Ahmed Belhani, Fabrice Aubepart, and myself, Nacer M'Sirdi. It has been done in the Laboratoire d'Informatique et Système of Aix Marseille University. It's entitled Smart Autonomous Greenhouse, and we will talk about modeling, design, and simulation as a variable structure autonomous system. Our project is to design a smart autonomous greenhouse. So we have chosen to use variable structure automatic system models in order to describe the behavior, the dynamic behavior of the greenhouse. This kind of modeling is very adequate for the case where the system interact with their environment intermittently. It gives a way to control this kind of system very easily. Another point of interest is that this smart autonomous greenhouse will be equipped with wireless sensors and actuators and acquisition tools driven by IoTs with wireless communications and decentralized tools. In the first step, we have chosen a very simple greenhouse, and this has 8 inputs, 4 from the environment and 4 from the controls. The 2 outputs considered here as the internal temperature and humidity. The 4 actuators designed for controlling the inputs are dedicated to heating, opening, ventilation, and brumization. Please note that all the measurements, acquisition, processing, and control are decentralized and driven by IoTs through wireless communications. The greenhouse dynamic is governed by the energy exchanges with the environment. These exchanges are governed by several switched phenomena. In one hand, we have the controlled functions like heating, opening, brumization, and ventilation. In the other hand, we have the sunrise, the wind, and the natural phenomena. So the model we have developed is composed by several functions, and these functions are weighted by zeta p, which are time functions depending on the behavior or the considered phenomenon. In the previous work, depicted by the pictures on the left, we have found that we have to split the day in 4 periods. The first one is the night, the second night break, the third day, and the fourth day break. We have defined 4 weighting functions depending on the time called zeta e, and these weighting functions are used to define the behavior of the physical phenomena. 4 other weighting functions are dedicated to the control of the 4 variables like heating, ventilation, opening, and brumization. Gathering the equation corresponding to all these functions is given in the equation 3, where you can see the zeta e weighting function for the partial models. This allows us to write the greenhouse model in a variable structure system which is modular. The measurements, acquisition, communication, and control are made by the following hardware architecture. The sensors are connected to a wireless network made up of connected nodes. The nodes are designed using a 32 microcontroller ESP32 integrating wireless communication. 3 wireless communication protocols are possible by this. The network structure is flexible. The data are gathered and processed on a microcomputer serving as a protocol server. This is connected to a 4G router for remote control. The Raspberry also hosts a programming environment allowing a remote user. As conclusion, we can point out about the flexibility of the communication protocols and the flexibility of the choice of the communications. This also allows to develop observers or virtual sensors to get non-measured variables. The proposed methodology is very interesting to develop new approaches, integrating new technologies like IoTs. And thank you.